All right, everybody, we are in for another treat. Riemann Sums, everybody's favorite topic right here. So I've got a graph. I've actually copy and pasted it 4 times. So we're going to go through this graph 4 times. I want us to draw a Riemann sum for a left hand, a right hand Riemann sum, a trapezoidal approximation, and a midpoint approximation. And we're not going to come up with any concrete numbers today. We're just going to kind of talk about how to do this. And then we'll look at one where if you're given a table, what do we do with that as well? So we're going to start off actually with the right-hand Riemann sum, because it's a little bit easier for this graph. And we're going to use 3 subintervals for each of our graphs today. But again, it looks like we're starting at 0. This could be any number over here. But if I see there's 3 intervals, we're just going to divide whatever this number is by 3. So for example, if this is 12, this is going to be 4 and 8, right? They're going to be typically equally spaced in the question. So a right-hand Riemann sum, we take our first subinterval, okay, and we're going to put a point on this graph on the rightmost part of the graph, so about right there. Okay, I'm going to put a point there, and from that point, I'm going to draw a line straight down and over to the other edge of the interval, which is right here. So this is the first rectangle. I would find its area by doing base times height. So for this example, it's going to be 4. The base is 4. The height is going to be f of 4, whatever the y coordinate is right up there. All right, so that's the first rectangle. The next one, our interval goes from 4 to 8. So again, we start on the right at 8. I'm going to put a point right here. And even though it's a right Riemann sum, we are going to go to the left and then straight down, straight down. And so this would also be 4, but now it's times whatever f of 8 is. So base times height. And then from 8 to 12, well, at 12, the graph looks like it's at 0. So I'm going to put a point right here, and this actually leads to no area when that happens. There's nothing here. It's a height of 0. All right, so I would end up taking these 2 areas, adding them together. Left-hand Riemann sum, we do the same exact thing from where we start to the end of our first interval. We're going to put a point on the leftmost point. So this one also ends up being 0 like the end of the last one, because that's where our point goes, at 0. So there's no height here, area of 0. And the next part, again, I would put the point right here on the left part of the interval, and then I would draw this over to the right, and then straight down, and straight down. And then from here to here, put a point about right there, okay, over and down. Now, notice on part of our interval here, this graph, like, this is way over approximating the area under the actual curve. This one was pretty close. This was way under. It has to do it has to do with when the function is increasing versus decreasing for a left-hand and a right-hand Riemann sum. That might come into play for like some justification type questions. Okay, so when the function is increasing, the left Riemann sum would under approximate. When it's decreasing, it looks like the left-hand Riemann sum over approximates, and then vice versa for the right-hand Riemann sum. All right, trapezoidal. So what a trapezoidal does is connect. We put a dot at both endpoints of the interval. So we have a point here, a point here. We're going to connect those 2 with a straight line, and then draw a line straight down to the x-axis on both parts. This actually ended up being a triangle because this was at 0, so it didn't actually create a trapezoid here. This middle part will make a trapezoid though. We have a point here. We're going to put one right here. Connect. We already have a line going straight down. One straight down right there. And then this last one will create another triangle here. Another right triangle. So with this, the area of our, first off, if it's a right triangle, you're just going to do 1/2 times base times height. But if it's a trapezoid, it's a very similar formula, 1/2 times the sum of the bases, base 1 plus base 2, times the height. Or the way that ours is, how these are kind of standing up, you could actually even think about it as the sum of the heights times the base. So this would be equivalent for what we're doing. 1/2 times the base. So like this would be the base, this would be the base, this would be the base, times the sum of the heights. You could view it like that instead. All right, so that's our area formula. We're going to find all three, obviously add them together. Here, if I drew these all properly, it would actually, the whole thing would under approximate the actual area. There's just a little portion we're not getting the area of in the entire thing. This part I drew kind of weird, but it's an under approximation because of the concavity of the function. So concave down for trapezoid would under approximate. Concave up would over approximate. And then lastly, a midpoint is exactly how it sounds. So take your interval, find the middle, put a point on the graph. You're going to go left, down, right, down. And it's just base times height. Same thing for this one. Put a point right about here. Left and over, right and over. And then same thing in that last interval right there as well. All right, I've given us a table of values. Obviously, I didn't actually put values. I used A, B, C, and D. So this is f of A, f of B, f of C, f of D. And just kind of randomly plotted them over here. Okay, so imagine these are numbers, right? 1, 2, 3, 4. They don't have to be equally spaced. They could be anything. All right, we're going to just talk about a left-hand Riemann sum or something like this. So if you're given a table of values, I would just very quickly sketch a graph. Okay, your x's might be equally spaced. They might not be. It's okay if they're not. You'll just use unequal intervals. So if I was to do a left Riemann sum from A to D, I would first start off by just going from A to B. Okay, so I would use the leftmost point. I would go straight over, and then like this. From B to C, find the point at B, straight over and down. From C to D, I would use the left point, which is actually down here. So I would go over to D, and we would draw it up. So this area we would view as being negative, and then you won't use the rightmost point on a left Riemann sum. All right. If it was trapezoidal, instead, I would connect the 2 points, right, like this. Kind of difficult to do here, so you probably wouldn't have a negative if it's trapezoidal. And then a midpoint, we wouldn't have enough. You'd have to know the point right in here, and right in here, and right in here, which we don't have that information. My point being, sketch a graph, and then draw the Riemann sum. It's going to help you find the area for that particular question. All right, so hopefully that wasn't too confusing, and you guys should be able to do the practice now. And as always, stay flawless.